Okay, let's do a little bit of alkane naming and just a little recap on structures and kind of how you name stuff. So let's start with some simple alkanes. So we just go through the alkane series just to remind ourselves of it. So we've got methane, which is CH4, and then we can go to C2H6, which would be ethane. So once we've got two carbons, we've got a choice of kind of how we can represent it. This is a molecular formula. Okay, so molecular formula. Okay, so this is literally just how many atoms you've got in the molecule. Whereas if we want to represent this structure a little bit more fully, we can do it like this, because it's actually made of two CH3 units joined together. That's probably the main way in which you'd represent ethane. You could also do a full structural formula, and a full structural formula is the one where you draw every single bond and every single atom. Now this gets very tedious once you draw very big molecules, which is why we have ways of drawing molecules which are much quicker, particularly skeletal formulas. But this here is a full structural formula. Okay, so if a question asks for full structural formula, you really do have to draw every single bond. So we go 1, C3, so we double it and add 2, remember? C3H8, then we'd have CH3, CH2, CH3. So the one in the middle you see has only got 2 hydrogens now because it's bonded to 2 carbons, and this is the last one I'm going to draw as a full structural formula, because otherwise this video would be extraordinarily long. We want to keep it as short as possible to get the key points over. Okay, now we can actually represent this in a skeletal formula and it would just be like that. Now each one of these points or bends represents a carbon atom. So that point there represents CH3. So an end of a line represents a CH3, and a bend in a line, if there's nothing else joined onto it, would be CH2. So that's a much quicker way of drawing a molecule. So we go to butane, C4H10, so that would be CH3, CH2, CH2, CH3, and you could draw it out fully if you wanted to, but then you'd get that, and that's butane. But of course, once we've got 4 carbon atoms, we have a choice about how we could arrange those carbon atoms. So we get this one here, or if we drew that in a shortened structural formula, you'd draw it like this. So notice the middle carbon only has 1 hydrogen on now, but it's bonded to 3 carbons. And this branch here, the CH3, is called a methyl group. So this would be methyl propane. So it's the longest carbon chain, which is important when you name these hydrocarbons or carbon molecules generally. So the longest carbon chain here, no matter which way you go, is only now 3 carbon atoms long. So this is a propane, which indicates 3 carbon atoms. And methyl, so that's 1 carbon atom in a chain, that's 3 carbon atoms in your main chain. So these are isomers. Okay, structural isomers. So these compounds here have got exactly the same molecular formula over here, but you can make, in this case, 2 different structures. If we go to slightly more complicated ones, let's go on to a new page. And let's jump up to something like heptane. So heptane would be C7H14, 15, 16. So double it and add 2. So let's not worry about drawing a full structural formula or even a shortened structural formula, because it takes a while. So when you draw a skeletal form, you start counting 1, 2, 3, 4, 5, 6, 7, like that. Okay, and that's heptane. And there's lots of ways you can arrange the atoms in heptane, okay, to get other molecules, other isomers. So we start with this one, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. And we could put a methyl group on. So we could take one of the carbons off the chain and add a branch to this. So this would be methyl, go back and spell, methyl hexane. Because the longest carbon chain now is only 4, 5, 6. And we've got this methyl group, and because it's on the second carbon atom, we'd put 2 methyl at the beginning, because we could have other places we could put it on now that we've got this many carbon atoms. So there's our 6 carbon atoms again. We could put the methyl group on there, and that would be 3 methyl hexane. Okay, so the number tells us where the branch is. You could have more than one branch, so let's drop the longest chain down to 5, and then I could put a branch on there, and I could put a branch on there. Now, there's lots of ways you could count 5 here. You could go 1, 2, 3, 4, 5, or you could go 1, let's go 1, 2, 3, 4, 5, doesn't matter, as long as it is the longest chain. And you'll see the methyl groups are on the second and the fourth carbon atom in this particular example. So this would be 2, 4, and because there's 2 methyl groups, we now need to put di in front. If it was 3, it would be tri, and if it was 4, it would be tetra. 4's uncommon because carbon only forms up to 4 bonds. So di methyl pentane. So 2,4-dimethyl pentane would be that one. Okay. And if you got, let's have an isomer where we've got an ethyl group. So let's have something a little bit longer. 1, 2, 3, 4, 5, 6, 7, 8. And here I could put an ethyl group there, and let's have a methyl group there. Now you've got to be kind of a bit careful when you look at these, when you're counting the longest chain. So we could go 1, 2, 3, 4, 5, 6, 7 and go down this branch, or you could go 1, 2, 3, 4, 5, 6, 7, 8, or 1, 2, 3. Lots of ways you can count it, but the longest chain here is 8. So you would have 1, 2, 3, 4, 5, 6, 7, 8, or I could have gone up there, it doesn't matter, it's 8, so it's an octane, this one. And when you've got more than one branch, if they're the same, then you'd keep the numbers as low as possible. So this one up here, you'd put 2, 4, there isn't really in choice there, but you want to keep the numbers as low as possible. If you've got more than one type of branch, the longer carbon branch takes priority, and that also comes first if it's got a lower letter. So ethyl comes before methyl, and it comes before it in numbering. So you might think this one you'd do 2 methyl, 1, 2, 3, 4, 5 ethyl octane, but you'd actually go 4, 5, 6, 7 methyl. So this one would be 4 ethyl. Ethyl comes before methyl because it's alphabetical. Then we'd have 7. Can't spell methyl. That's meant to be a methyl octane. Okay. Rather than the numbers being the other way around, because the bigger group takes priority, so that gets the lower number. And then the E comes before the M. So that's 4 methyl 7, 4 ethyl 7 methyl octane. It's unlikely you get anything even remotely that complicated. Probably the most commonly asked about one in terms of lots of branches is this one. This is an isomer of octane as well. It's an isomer of this compound here. And this one is 2,2 because you've got two methyl groups on the second carbon. 2,2, and I've put one on the wrong place. That one there. 2,2,4 rather than 2,2,3. 2,2,4 tri methyl, whoops, pentane, not octane, it's an isomer of octane. There we go. Okay, and this one here is sometimes called isooctane. And if you look at petrol pumps and you'll see relative octane numbers, it's actually all about this compound here, 2,2,4-trimethylpentane, which has an octane number of 100, although that's not in most specs now. The other thing I would just flag up is cycloalkanes. So you can have rings, you don't just have to have a straight chain. So here we had C6H12, which could be an alkene, but we're talking about cycloalkanes here, so you join two ends of a chain up. And cyclohexane would be normally drawn as a hexagon like that. Okay, and each one of these points here represents CH2, so that would be cyclohexane. And then you can have others. You can go all the way down to, that's really badly drawn. It's meant to be a regular triangle. This one is the smallest one you got, because to make a ring you're going to have at least 3 bits to it. So this one is cyclopropane. Okay, and you can have anything in between or higher than cyclohexane as well. This is a very strained ring, so it falls apart quite easily because the bond angle there is 60 degrees. So your bonding pairs of electrons are really close together, so you get a lot of repulsion, so those bonds are not very strong. And if you had branches, you won't get many of these. Let's put in a couple of branches here. So that would be 1, 2, 3. Rather than counting it around the other way, you get longer numbers, bigger numbers, not longer numbers. 1, 3 dimethyl cyclohexane. Okay, so you might get cyclic ones as well. So that's something just to bear in mind. Anyways, we'll leave it there. That's long enough on that.